But today we are going to be learning about derivatives of trig functions. All right, so grab a pen, be ready. So we've already found the derivatives of sine and cosine. We can write these derivatives in a number of ways. We can either write that f prime equals cosine x, or we could write it as d dx, the derivative of sine x, is cosine. Here we go. The f prime x equals negative sine x, or we can write d dx, meaning we're taking the derivative with respect to x of cosine x as negative sine x. So we now investigate the derivatives of other trig functions. Okay, so let's talk about the derivative of tangent. Well, the word tangent means sine over cosine, or sine x over cosine x. So we would actually have to use the quotient rule in order to find that derivative. So if we're going to find the derivative, then we would actually, the quotient rule says fig minus gif over g squared. So we're going to do the derivative of the top one, that's cosine x, times the denominator, which is cosine x, minus gif, the derivative of the bottom one. Well, the derivative of cosine is negative sine, so we're just going to have to change the symbol there and write sine x. And then f, the top function, is just sine x. All right, so I hope you're pretty happy about that numerator. I know I am. The reason I'm happy about that numerator is because it's cosine squared plus sine squared. So anyway, g is going to be squared. The denominator is going to be squared, so that's cosine squared. So yeah, I told you that I was pretty excited about that numerator because it's basically sine squared x plus cosine squared x. And I know that that is going to be 1. All right? So if the numerator is just 1, then I have 1 over cosine squared is the derivative. Well, 1 over cosine squared can actually be simplified as well, because the definition of, secant is 1 over cosine, so this is just going to be secant squared x. So now, if you ever forget how to find the derivative of tangent, now you have the tools to find that derivative. Okay, so f prime is just secant squared x. So if I want to find the derivative d dx of tan x, that's going to be equal to secant squared x. All right? And this other note says, in a similar fashion, we could have found the derivative of cotangent x. And what would have happened is there would have been a little sign change in there, and you would have got negative cosecant squared x. So these are the first two that we'll try to put in our brains for the day. Okay? We'll do another one. We're going to find the derivative of secant. Okay? Now, the derivative of secant can be, well, the word secant is 1 over cosine, so basically what we're going to do is use the quotient rule on 1 over cosine. Assuming that the top is f and the denominator is g, our formula fig gif should work for us. Fig gif over g squared. All right, so the derivative of the top is just 0. So I don't need to even write the other function down, but I might write it down just so that I can keep track of my work, right? Gif, so that's g prime, so I have to take the derivative of cosine, which is negative sine, so I need to change that symbol, minus negative, right? And then f is just 1. So right now I'm just getting sine x on the numerator, and in the denominator I'm going to get cosine squared x. Okay? So, sine x, I'm just going to rewrite this as cosine x times cosine x. And I think that you will be able to take it from here. What is sine over cosine? Sine over cosine is just tangent, right? So this is basically like tangent x times 1 over cosine x. Well, we know what 1 over cosine x is also. 1 over cosine x is secant x. So, actually, whenever I write this, I typically write it as secant x tan x. And I don't know, maybe it's because it's in alphabetical order. Maybe that's the reason why we write it as secant x tan x. But that's the way we typically see that derivative. So, what did we just learn? We learned that the derivative of secant x is secant x tan x. And I think this is one of those ones where like the answer is always going to be positive, something like that. I don't know if that's going to mean anything to you at this point, but there you have it. So it says in a similar argument, we can do this on our own time if we feel so inspired, but we could say that the derivative of cosecant x is going to be negative cosecant x cotangent x. So there's a lot of similarities with these derivatives that, like, if you get one in your head, then you can get the other one in your head pretty simply. Okay, so on the back of the page is just a list of the derivatives. I don't think I'm going to spend the time. Actually, you know what? I will spend the time to do this. So let's go ahead and do this. The derivative of sine x is cosine x. The derivative of tangent x is secant squared x. And the derivative of secant x is secant x tan x. Now on the right side of the page, this is going to be okay, all right? Any of these co's, anytime you see a co, that means that we're going to put a negative in front. So negative sine x. Cotangent, so I know it's going to be negative. Now this one says secant squared for this, so over here we're going to say cosecant squared x. And over here it says on the left secant x, derivative of secant x tan x, so the derivative of cosecant x is negative cosecant x cotangent x. So I hope that some of that kind of makes sense. Now what's highly tested? The highly tested ones are the ones that I've just placed a dot on. The less tested one would be the derivative of cotangent or the derivative of cosecant. Okay? So this derivative of secant probably least tested out of those top four, but it's still going to be on worksheets, and it could be on your unit tests, okay? But as far as the AP exam, you may not see it, okay? But be ready for it, you know? Be ready for it. No reason not to stick it in your brain there. All right, so I've already mentioned that an important thing to note is that all the co's have a change in sign. So I did my best, you guys, to teach you about the derivatives of trig functions today. Now we just need to practice. All right, so make sure that you guys get your practice in, because math gets so much more beautiful the more you know about it, and the more time you spend with it. All right, so take care, have a great day, and we'll see you in another video.